Welcome to my presentation. Microwaves have four basic components. Let's get started. The magnetron. The magnetron is what produces the power that heats up our microwave. They're typically tuned to 2.45 gigahertz. The magnetron itself is a vacuum tube with two magnets, hence the name. Inside of the vacuum tube, radiating electrons form a spiral that chase the alternating electric fields. An antenna is hooked up to one post, and the rate that this field changes is its frequency. The magnitude of the electric field generated will be its intensity. But why 2.45 gigahertz? Well, water is a polar molecule. It's more negative on one side than the other. In the presence of an electric field, these molecules will align themselves, exerting a torque on them, breaking the hydrogen bonds around them, and creating friction. This friction creates heat, and the frequency was determined because if it was a higher frequency, it wouldn't penetrate enough because it would be so far absorbed, and if it was a lower frequency, it would penetrate too much and it would not be absorbed. The transformer. The transformer steps up our wall output of 120 volts to a usable 2200 volts that our magnetron uses. Here we can see that the primary coil has significantly less turns than the secondary. Given these arbitrary values that are pretty standard, we have about 18.3 times more turns in the secondary. A current flows through the primary, generates an electric field that is felt at the secondary. The secondary then generates a current that would create a magnetic field that opposes the changing one. The antenna from the magnetron radiates in all directions, so a waveguide is used to help them propagate uniformly. Inside the chamber where we cook our food, the waves are taken from the magnetron, reflected, and then reflected again. This creates standing waves. These standing waves have peaks higher than our incident and reflected waves. At these peaks, called antinodes, you will find hot spots, and at these nodes where they cancel out, you'll find cold spots. Chamber of a microwave is designed to be a half of a wavelength. This is so that the re-reflected beam will not have a phase shift from the incident beam itself and will just add constructively. There's also a Faraday cage at the front of our microwaves that allow light to go through, but not the waves to propagate outwards. What's the deal with metal? Well, smooth metal objects reflect waves, creating new standing waves that can damage our microwaves. Pointy metal objects collect electrons on their tips, and with the collection of electrons, they'll generate an electric field. And when the field is high enough, they will go to the next nearest conductor with a lower electric field. Thanks for watching.